All right, folks, we do have a lot of news popping, but this is the biggest by far. A 1.6 X class flare, Earth facing. Okay, this guy who I uploaded a video last night, I just happened to stop back by on his channel, and he's still talking about this is a big deal. So we're gonna get into it and check him out and see what he got to say.
The sun is absolutely going crazy right now with explosions across its surface, the Earth facing side, also some on the far side. The biggest now being a 1.6 X class flare, boom shakalaka, from Sunspot Group 3936. In fact, this was a 1.6 and a 1.1 X class flare, though in general it was just a long duration solar flare. We're still awaiting coronagraph imagery for this to see if it pushed out a coronal mass ejection, but just looking at this 131 angstrom SUVI imagery here, we do see a push of material off the surface in this direction more towards the west, and so it is likely that this did dislodge part of the corona and flung it out into space, though it's likely going to go ahead of the Earth to some degree, though there may be an Earth-directed component. So after countless M-class flares yesterday and a 1.1 X-class flare as the peak, we now have an even stronger X-class flare today, December 30th, Universal Time, with this 1.6 X-class flare. Hey everyone, and welcome back to the channel. If you're new here, I'm your space weatherman, Stefan Burns. Here we are looking at radio propagation across the globe. We see that R3 radio blackout occur right over Australia and Southeast Asia. And effectively what this is showing here is the sunlit side of the Earth. But when we have big explosions on the sun, known as solar flares, they release more vibrational wavelengths of light like extreme ultraviolet light and X-ray light. And that causes greater ionization of the ionosphere, the uppermost part of the atmosphere, which has a weak plasma to it. And so it causes this signal degradation. We see that effectively blasted Australia and Southeast Asia, degrading radio propagation characteristics for a while at that time. Now starting to subside as I'm filming this. It was a pretty long duration flare. Let's give that X-ray flux a direct look. Here we have our past 30 hours or so of X-ray flux as measured by the GOES satellite in geostationary orbit at 5.6 Earth radii. And so we can see all these solar flares that have occurred. They are measured by their X-ray flux. Every single spike here is basically an M-class flare. Anything over this line, if it's a spike, it's an M-class flare. We see that 1.1 X-class flare that I covered in my live stream earlier right here, just barely getting into that X-class territory. We see that here, the highest designation possible for a solar flare. There is a gamma designation, a Y designation that is at an X10 and beyond, but that's not used by everyone. So you go from A class all the way to X class, and we are only down in this range during solar minimum. During solar maximum, it becomes more common to be in the C, M, and X class range. You're only reaching M and X during big periods of solar activity, like right now, where you have more than probably 24 M-class flares clustered in here, and now with this 1.6 X-class flare, and as I mentioned earlier, actually a double flare if you want to be really precise, because we see this 1.6 right here. I can get the cursor on there, and we see it's 1.6 or so at the top, a 1.59 and also 1.63. You combine those, you get 1.6, and then it goes down and then briefly goes back up again right here. That's that 1.1. So technically it is a double solar flare, but really just one long duration push of energy from the sun. These magnetic reconnection events are occurring just off the surface, emitting light photons outwards that then reaches our planet in just 8.3 minutes, causing that shortwave radio blackout. There are a few ways that we can look at the sun. For example, we can image what's happening on the surface and we can get in close, or we can look at what's happening in the solar corona and in general how that bleeds out into the solar wind. So here we have our C3 coronagraph. This allows us to see what's pushed off the sun and what may be heading towards Earth as a solar storm. This goes back to the 29th of December, the beginning universal time, up to now. So it's about 26 hours of data showing all that activity that's occurred over the past 26 hours and a little bit more. You see a whole bunch of these pushes off the center here. So just watch this. We get a faint one right there. Then we get a big full halo right there. And then we get a couple more, specifically right there is another. We see this circle right there. That white circle is the sun. They put an occluding disk over it, so they represent the size of the sun with that white circle. And then this is all the solar corona bleeding out into the solar wind. You see the stars behind the sun there. So when you have these waves of energy propagate out like this towards you, looking at the chronograph, you either have a solar storm headed towards Earth, or it is an optical illusion. You have a solar storm headed away from the planet because there was an eruption on the far side. But in fact, all this activity here seems to be Earth directed because the Earth facing side right now has all the sunspots on it. Sunspot counts are over 250, almost at 300, which is a very high value for a solar cycle in general. We are in solar cycle 25 maximum. We've seen solar activity like this before back in May of 2024, back in August, back in October, and now we're seeing it again at the very end of the year. We are still awaiting fresh chronograph imagery for that long duration 1.6 X-class flare, and that is what's going to definitively tell us whether we have a coronal mass ejection that launched from that flare and whether it's headed towards Earth or not. But we do know there's already a coronal mass ejection headed our way. We have a solar storm inbound. We have our space weather model from the UK Met Office to give us a sense of what type of impact that's going to be and the time of it. So impact is on December 31st at approximately 1400 universal time. We see this plasma wave launch from the sun. This is all from activity on the 29th. Here we see this plasma wave. Also in our south-north view, this is our top-down view, the sun, the earth, looking on the ecliptic plane. So pretty much a surefire square shot hitting the earth on the 31st. NOAA has issued a G3 geomagnetic storm warning. For that, the scale rating goes to 5. So this is a geomagnetic storm that's in the middle, but already that's pretty powerful. So we're going to have aurora move from the Arctic Circle and the Antarctic Circle to more high to mid latitudes. If you're in Canada, you're very likely to see aurora. If you're in Northern Europe, you're very likely to see aurora. If you are maybe perhaps even in the northernmost part of the United States, there's a high likelihood that you will see aurora on New Year's Eve, bringing into New Year 2025. And an interesting modifier to this is the fact that we have a new moon on the 30th. So one day before this solar storm impact, the moon will be positioned in front of the Earth and the sun. And when it gets to December 31st, the moon is effectively still positioned pretty much in front of the Earth and the sun, taking some of the brunt of any solar storms that will sweep by. We have some data here going from 1874 to 1954. So this is 80 years of data connecting geomagnetic disturbances with the phase of the moon. It's really interesting because we see that there are greater geomagnetic disturbances during the full moon, which is when the moon is in Earth's magnetotail, more able to interact with the plasmasphere. Remember, a geomagnetic disturbance is a change in the magnetic field strength. And so it's a connection of the plasmasphere, the ionosphere, the magnetic field, a whole bunch of things. But what's really clear, what really stands out with this data from this time frame is that you have the least amount of geomagnetic disturbances during a new moon. It doesn't mean you have none. We see here our scale rating, but in general, you have less, and they're of a lesser severity. And so we do have a little bit of a contradictory nature occurring and unfolding on the 30th and the 31st, where we have this new moon, but now we have quite a few solar storms inbound, and they look pretty large. And so we'll see how the two work together. But it's very likely that this is not going to cancel out these solar storms. It may just lessen their impact a little bit more than some people may expect. What we see with the solar wind passing by the moon is that it creates disturbances in the solar wind. And so those disturbances are kind of hard to model. We don't know if that's going to make the storm more severe or less severe. But in general, we see that with this data set, the new moon being in front of the Earth, in between the Earth and the Sun, actually reduces the severity of geomagnetic.
Okay, guys, so I just wanted to bring you that. That is very important, folks. We have a X-class flare. We have multiple, because yesterday when I was watching him live, the sun was exploding with bursts of energy, and it's headed our way starting today going into tomorrow. So let's see what happens. It's a whole lot of stuff happening at the end of the year, and so we're just going to continue to pray that we are worthy of escape, folks. But the signs are on the wall. It's written. Peace.